G'day, how you going? And welcome to the 8th episode of Over the Moon, the podcast where I talk to you about all things space related. Today's podcast episode is a little bit delayed, just like our topic has been numerous times, the James Webb Space Telescope. The James Webb Space Telescope is a space telescope that has been in development since 1996. It was going to be launched in 2007. It was then unfortunately delayed. In 2005, it underwent a large remodeling. It wasn't done being developed until 2016, and then it underwent extensive tests. In 2018, it was, however, once again delayed as the sun shield was ripped off during its tests. The telescope is currently set to launch in 2021. Work on it, however, has been unfortunately delayed due to the current coronavirus pandemic. Hopefully in 2021, the JWST, or James Webb Space Telescope, will be launching on an Ariane 5, an European Space Agency rocket. When it is loaded on the Ariane 5, the James Webb Space Telescope will have to have the mirror loaded pointing down, and it's all going to be folded up because of how big it is. The telescope is going to be the largest, most powerful and complex space telescope ever, and is 100 times more powerful than the Hubble Space Telescope. The main piece of the space telescope is known as the Science Instrument Module. The Optical Telescope Element, or OTE, which is a large gold mirror and a smaller secondary mirror. The primary mirror is made of 18 hexagonal mirrors. The mirrors are made of metal beryllium. These portions are then coated in gold so as to capture faint IR beams, or infrared beams. Space telescopes capture IR or infrared beams, and then they are converted into full color images once sent back to Earth. In the centerpiece of the primary mirror, there is a smaller secondary mirror. The secondary mirror reflects the light that has been gathered from the primary mirror into the ISIM, or Science Instrument Scientific Module. That's wrong. The ISIM is placed behind the OTE. Inside the ISIM houses all the scientific instruments and cameras. Inside the ISIM is a near-infrared camera, or NIRCam as it is referred to, a near-infrared spectrograph, or NIRSpec, a mid-infrared instrument, or MIRI, or MIRI, and a fine guidance sensor. Under the OTE is something called the multiplayer sun shield. The multiplayer sun shield is 5 layers of heat shield. The multiplayer sun shield protects all of the scientific instruments like the OTE and the ISIM from the heat of the sun so they don't just go poof. On the bottom of the heat shield is a trim flap. The trim flap works by balancing out the solar pressure. The trim flap is more useful than RCS, or reaction control systems, as it requires absolutely no fuel or gas when refocusing the telescope. In front of the trim flap is a solar panel array. The solar panel array is 6 meters long. This solar panel array is all that powers the telescope. It gives the James Webb Space Telescope a maximum of 2,000 watts of power for all of the instruments. On the center bottom of the heat shield array, there is an antenna which is pointing towards Earth. The antenna is used to send all of the data back to Earth. NASA receives the data using the DSN, or Deep Space Network, which is an array of satellites. In front of the Earth-pointing antenna is the spacecraft bus. Inside the spacecraft bus is most of the steering and control machinery. That includes the computer and reaction wheels. Inside this bus is 6 major different machines. The first one is an electrical power subsystem. The electrical power subsystem takes the sunlight that the solar panel arrays catch and then converts it to the power for all of the machinery. The next system is known as the attitude control system. The attitude control system detects the degree and angle of the James Webb Space Telescope. It also makes sure that the James Webb Space Telescope keeps a stable orbit while in space. It also tells the trim flap where to go and how, so the science instruments can observe what it is they want. The next system is the communication system. The communication system receives the command from ground control and then passes the message along the James Webb Space Telescope. It also transmits the science back to Earth. The next system is the command data handling system. The command and data handling system has inside it a computer called the Command Telemetry Processor, or CTP. The Command Telemetry Processor takes command from the communication systems and sends them to the correct places. The CTP also houses all of the memory and data known as the Solid State Recorder, or SSR. The next system is the propulsion system. The propulsion system houses the fuel tanks and can move the James Webb Space Telescope when told by the attitude control system. The second system is the rocket and propulsion system. I just said that. The James Webb Space Telescope uses 2 different rockets. One is called the Secondary Combustion Augmented Thrusters, or SCAT. SCATs are used for keeping a stable orbit and not being pulled in by Earth's gravity. If you want to learn how orbits work, I did a brief one on one of my other episodes. There are also 2 pairs of SCATs on Webb, or a James Webb Space Telescope, which is usually referred to as Webb. The second type of thruster is known as MRE-1. There are 8 different MRE-1 engines on the James Webb Space Telescope. These are used to keep the attitude and momentum of the telescope. The final system is the most simple, and that is the thermal control subsystem, which is a smaller heat shield made for the spacecraft bus. Today's That's the Reason topic is, why was the lunar landing beneficial? On July 20, 1969, Apollo 11 launched. Apollo 11 was watched by millions from their home on that day. Some may, however, ask why the lunar landing even matters. And that's what I am going to answer for you today. The moon has always been a point of interest for astronomers, as it is our closest celestial object. People have suspected there are aliens or a man inside the moon, but of course these are all stupid theories. On Apollo 11, after the landing, Neil Armstrong and Buzz Aldrin collected rocks and dirt. They collected these rocks because theories of where the moon came from have always been going around. In my first episode, Theories of Creation, I explained a few of them. That is, part of Earth, another asteroid, and another one which I cannot remember. When humans collected rock and dirt samples, interesting story. When after Buzz Aldrin and Neil Armstrong had filled up the box that they had for moon rocks, Neil Armstrong realized that there was a bunch of tiny crevices, so he decided to fill that with dirt. But as I was saying, when humans collected rock and dirt samples to be scientifically experimented on and looked at, one theory prevailed, and that is that the moon came from the Earth. Another great advancement to do with the Apollo 11, the entire Apollo mission, was for technology. NASA showed America and Russia and many other countries just what they are capable of, as they managed to put a man in space and onto Earth's one only natural satellite after just 15 minutes in orbit. In conclusion, the lunar landings were important as they proved and provided us the information of where the moon came from, and that America and NASA are very capable in the space age. I hope you enjoyed this episode. Hit like if you liked it. Hit subscribe if you want to see some more. And next week, we will be talking about the up-and-coming Artemis program, the second program to put the next man and first woman on the moon.